In one of India's poorest regions, a group of young engineers put forward an idea so bold and unconventional that even Americans would tip their hats to them. They proposed building roads out of coconut waste. Sounds like fantasy, but it is absolute reality. Using discarded coconut husk, the engineers managed to create strong, eco-friendly road surfaces that literally changed the lives of entire communities. So what is the secret of these Indian innovators? How did they manage to turn ordinary agricultural trash into the foundation for modern infrastructure? Let's break everything down in order. The southern regions of India live in a tropical climate all year round. Here, people experience heavy downpours every year in 2 consecutive monsoon seasons, and then a sharp shift to exhausting summer heat. This ruthless climatic cycle literally destroys roads. During the monsoons, the soil base is washed out by streams of water, and during the heat, the road surface cracks and breaks down because of the constant expansion and contraction of the material. Faced with this problem, local engineers had a choice: either patch roads endlessly or find a fundamentally new solution. That was when they turned their attention to coconut fiber, a material long known for its high tensile strength and natural resistance to rotting. The engineers realized coconut fiber could become an ideal means for strengthening soil and protecting it from erosion. This is how the idea of coconut geotextiles was born. A real breakthrough in building durable, affordable, and environmentally clean roads. This material is a 100% natural fabric, completely woven from coconut fiber. It reliably fixes the soil, distributes the load evenly, and protects the base from being washed out during the rainy season. At the same time, the geotextile freely lets water pass through without disrupting the natural drainage processes. The soil retains its structure, and the surrounding ecosystem remains in balance. And of course, the path of coconut geotextile begins with the coconut itself. Southern India is rightfully considered the true coconut capital of the country. Here, more than 19 billion coconuts are harvested every year. Every part of the fruit is used as efficiently as possible. Coconut water is bottled for drinking. The white flesh is processed into flour or pressed into oil, and even byproducts find application in the food industry. Later, we will definitely return to these processes. But right now, what interests us is precisely what used to be considered waste: the coconut husk, from which valuable fiber for geotextile is obtained. Coconuts are usually harvested about a year after the fruit forms. This is exactly when the husk reaches the optimal condition for extracting fiber. Experienced harvesters climb coconut palms up to 10 meters tall, using neither safety gear nor protective equipment. In their hands, there is only a machete. They cut whole clusters and let the fruits fall freely to the ground, where each coconut can weigh more than 3 kilograms. This method is far from safe and not always efficient. In difficult conditions, on uneven terrain or with palms that are too tall, workers use long poles, sometimes reaching 10 meters. This method allows them to stay on the ground, but the coconuts fall with great force, hit stones or tree roots, crack, and lose quality. After harvesting, the coconuts are delivered to a collection point where the cleaning process begins. The fruits are split open and the husk is separated from the hard shell using a sharp wooden or metal spike. An experienced worker is able to clean from 500 to 1,000 coconuts a day. It all depends on their size and moisture level. The fibrous oboluchka makes up approximately from 35 to 45% of the total weight of the coconut. It is in this layer that the valuable coir fibers are hidden. The cleaned coconut husk is loaded into trucks and sent to the nearest processing facility. There it is unloaded onto open storage plощadki. On average, such factories process up to 2 tons of coir per day. The husk is spread evenly and left under natural sunlight for a period of 2 to 4 weeks, depending on the season. During this time, the moisture content of the material decreases approximately from 65% to 15%. This stage makes the husk softer and significantly obliquate the subsequent separation of fibers. huge dried piles of coconut husk are picked up by heavy frontale loaders. The machines scoop up the material and move it into large transport containers, from which the next stage of processing begins. The collected husk is unloaded into a receiving hopper which directs the raw material to the conveyor line. The belt moves at a clearly calibrated speed, ensuring a continuous and even feed of material into the processing equipment. Next, the husk goes into a decortication unit. Inside, rotating blades and tearing rollers literally break the coconut obolichka apart, releasing the long coir fibers. The fibers come out in tangled bundles, while the pith and ostatki of shell are separated and removed. The resulting material is sent to a rotating drum sieve filter, which screens out dust and small particles. After filtration, clean, long and strong fibers remain, ready for the next stage. The cleaned fibers are taken out to open areas and again spread under the sun. This time, the process lasts from 3 to 7 days. It all depends on weather conditions. During this time, the moisture level decreases approximately from 15% to less than 5%. This state stabilizes the material, makes it lighter, cleaner, and fully ready for transportation to the weaving factories. After drying, the fibers go to the pre-twisting zone. Here, spinning machines operate around the clock, forming even, stable bundles of fibers with high strength. The productivity of this section reaches approximately 3 tons of fiber per day. First, the fibers are fluffed and sorted by length, then twisted into uniform strands with reliable tensile strength. This is necessary so that the threads do not break and do not tangle during the weaving of the geotextile. Depending on the requirements of the final product, the fibers can be additionally refined, becoming thinner or softer to match different types of looms and weaving density. The prepared bundles are carefully rolled up, tied, and sent to the weaving shop. In the weaving area, the coir bundles are wound onto large spools and fed into the loom. It is here that the formation of the geotextile fabric begins. The longitudinal threads are stretched into parallel rows, forming the so-called warp, the frame of the future polotna. Then the transverse threads are woven in using guide needles and bars, creating the strong, interconnected pattern characteristic of coconut geotextiles. The loom works in an even, measured rhythm. Each pass lays the fibers with high precision, ensuring the same cell spacing. This is critically important for proper drainage and soil retention. Gradually, the fabric acquires its characteristic rough texture, but at the same time demonstrates high tensile strength, which makes it ideal for strengthening soil and protecting against erosion. After weaving is completed, the rolls are carefully inspected. The uniformity of the weave, the thickness of the fabric, and the strength of the knots are evaluated. Everything must meet construction standards. Then the geotextile is rolled into large rolls, ready for transport to road sites, slope reinforcement areas, or landscape restoration zones. On average, from 100 kilograms of coconut fiber, it is possible to obtain from 250 to 300 meters of geotextile with a width of 1 meter. The cost of such material ranges approximately from $1.20 to $1.80 per meter, depending on the thickness and density of the weave. The finished rolls are loaded into trucks and sent to the construction site. At the site, they are unloaded manually or with lifting equipment. It all depends on the length and mass of the rolls. Using long, continuous polotna significantly simplifies installation, allowing you to do without unnecessary joints and overlaps. Before laying the geotextile, road rollers pass over the trassa of the future road, compacting and leveling the grunt. Irregularities, rickly areas, and excess material are removed from the surface. This makes it possible to create a firm, even base onto which the coconut geotextile can be laid without folds and gaps. Such a prepared layer plays a key role. This is exactly what ensures tight contact of the fabric with the soil and the even performance of the material throughout the entire service life of the road. At the construction site, the rolls are placed at the beginning of the road line. A work crew gradually unrolls the geotextile along the route. carefully ensuring that the fabric lies strictly along the axis and fully contacts the soil surface. The material is fixed using pegs, pins, or steel anchors, preventing displacement during further work. Accurate laying and the absence of folds are critically important. This is exactly what ensures effective drainage, soil eudogenia, and even load distribution. After fixation, the coconut geotextile begins to perform its main function. It holds soil particles, not allowing them to shift even during heavy downpours, characteristic of the monsoon climate. Thanks to its natural structure, the material distributes pressure from traffic and prevents local subsidence on weak and unstable sections. This makes it especially effective on slopes, riverbanks, in zones with soft soils, and in areas prone to erosion. When the geotextile is securely fixed, a layer of crushed stone is evenly distributed over it. This layer fixes the fabric and serves as the primary load-bearing base of the road. Next, a road roller passes over the zapolnania, compacting the material and forming a strong and even surface. The thickness of this layer usually ranges from 10 to 15 centimeters. This is exactly enough to ensure stability before the next stages. Next, a layer of soil is laid over the crushed stone. It levels the base, forms a uniform surface, and additionally protects the geotextile from direct pressure and mechanical damage. After this, another layer of large crushed stone is applied to the roadbed. This stage strengthens the load-bearing capacity of the structure and significantly improves drainage. The roller again passes over the entire length of the road, securely fixing the stones and creating a firm base fully ready for the final percrete. When the base is stabilized, the Dalnaci stages are no different from building a regular asphalt road. The asphalt is laid evenly, compacted in several passes, and brought to the required indicators of smoothness and density. In the end, a road is obtained that outwardly is no different from a standard one, but at the same time serves significantly longer. It cracks less, tolerates temperature fluctuations better, and maintains integrity even in harsh climatic conditions. At this stage, the construction of the road can be considered complete, but our story does not end here. As was mentioned at the very beginning, the coconut is a truly universal fruit. It has many more amazing applications that are worth telling about separately. And very soon we will move on to other coconut technologies that will definitely surprise you. Coconut water is a refreshing drink that almost everyone has tried at least once in their life. However, in its fresh form, it is extremely difficult to transport and store. So to enter the mass market, it undergoes special processing and packaging. At the processing facility, coconuts are fed into a fully automated system. A precise drill carefully makes a small hole in the hard shell, through which the liquid is extracted. Immediately after extraction, the coconut water goes into a cooling tank with a capacity of up to 1,000 liters. There, the temperature is lowered to 4 degrees Celsius. This allows the maximum amount of nutrients to be preserved. The cooled liquid passes through a filtration system where impurities, residual particles, and oils are removed from it. Then the coconut water is briefly sterilized, destroying bacteria, and cooled again. Such a gentle process allows it to retain its natural freshness, taste, and nutritional value. After sterilization, the drink is sent to a modern packaging line. On the line, coconut water is poured into pre-sterilized multi-layer carton packages. They protect the product from light and air, significantly extending shelf life. The entire line operates in automatic mode with high precision. Productivity reaches approximately 6,000 packages per hour. Thanks to this, coconut water retains freshness and is ready for large-scale distribution all over the world. While coconut water becomes a drink, the flesh goes a completely different route into the health and beauty industry. After removing the hard brown shell, soft, creamy white flesh is collected. From it, valuable coconut oil is extracted, a true natural gift, rich in polyzny substances. This oil nourishes hair, softens the skin, and supports the health of the body from within. Pieces of coconut flesh are cut and sent into an automatic washing system. Powerful jets of water under high pressure completely remove sand, zagrznienia, and residual impurities. At some facilities, warm water or mild disinfecting solutions are additionally used for deeper cleaning. The cleaned flesh goes to the grinding stage. Sharp blades rotate at high speed, turning the coconut into a homogeneous mass. Then the mixture is sent to a mechanical or cold press. Under strong pressure, the oil is separated from the fibrous part. This method allows the natural aroma and high degree of purity of the product to be preserved, preparing it for subsequent filtration. After filtration, pure coconut oil is moved to the packaging area. An automated system precisely does zero-it the oil into glass jars or plastic bottles. Then the container is hermetically sealed and labeled. The entire process takes place under sterile conditions, which guarantees quality, freshness, and a long shelf life of the product. In addition to oil, coconut flesh continues its transformation and becomes the basis for coconut milk, a nutritious plant-based drink with a rich texture and a murky aroma. The process begins immediately after harvesting in order to preserve maximum freshness and the vkusowy qualities of the raw material. The flesh is thoroughly ground to the state of a thick mass, after which the extraction stage is launched. After grinding, the coconut mass is heated to a temperature of approximately from 60 to 70 degrees Celsius. This process lasts from 30 to 45 minutes. During heating, fats rise to the surface and harmful microorganisms are destroyed. This stage plays a key role in ensuring the safety and quality of the future product. When the fractions are separated, soft, velvety coconut milk is ready for the next step. Coconut milk goes to a fully automated filling line. Empty metal cans are pre-sterilized in a chamber at a temperature above 120 degrees Celsius, which completely eliminates any bacteria. After that, the milk is carefully poured into the cans, and the lids are hermetically sealed within a matter of seconds. This approach guarantees safety, stable quality, and a long shelf life of the product. One factory is capable of producing up to 2,000 cans of coconut milk per hour. Then the cans of coconut milk pass through a high-pressure processing system. This technology uses extreme pressure, up to 600 megapascals, to destroy bacteria without using high temperatures. Thanks to this, the product retains its natural taste, color, and nutrients significantly longer than with traditional thermal sterilization. After processing, an automated system carefully forms boxes. About 24 cans are placed into each carton. The boxes are hermetically sealed and labeled with barcodes for convenient traceability. Now the product is fully ready to leave the plant and head to store shelves and consumers' kitchens all over the world. This is how the amazing journey of the coconut comes to an end. From road surfaces reinforced with geotextile made from coconut fiber to everyday use products. From sustainable construction technologies to food, health, and beauty, the coconut clearly proves that it has no unnecessary parts. See you in the next video, where VD team will continue telling about the processes that turn ordinary things into something truly outstanding.